Hi everyone. In this video, we are going to solve equations and also using equation to solve some application problems. We have 5 learning objectives. So basically, it's about solving equations involving one variable and also solve some right triangle application problems. So let's look at some examples. And the first one, we are going to solve this equation. You see, this is one variable equation, right? And when we solve an equation, our goal or direction is to have this variable, this unknown, on one side by itself. So eventually, this variable t is going to be on one side by itself. So t on one side, and another number on the other side, we call it the answer, right? That's general direction when we solve any equation. So in this case, in order to have t on one side by itself, I need to get rid of 6. I need to get rid of 4.8. And usually we want to get rid of this number by itself first, instead of the number in front of a variable. So to get rid of 6, we do opposite operation. So what do we do then? We look at the sign in front of the number. So this one is minus, this one, there's no sign, means plus, okay? We do opposite operation, which is minus, and we have to do it on both sides of the equation to keep the equation balanced, to keep the equation equal. So this canceled, again, negative 4.8 t. The other side, if we do subtraction, we're going to get negative. Let's do the calculation using calculator to make sure I don't make any mistake here. And the light. I need 3.552 subtract 6. So I get negative 2.448. Now all I need is to divide by this number in front of t. So generally speaking, whenever we want to eliminate an item or a term inside the equation, we want to do the opposite operation. So now we need to get rid of this negative 4.8 from this whole thing, right? This is the multiplication in between. We want to disconnect it. We want to undo this multiplication, which is division, okay? We divide by whatever we have in front of the variable, and we do it on both sides. Any number divided by itself is 1. That's why we divide by this whole thing. We get t. The other side, we just need to do division. When you use a calculator, you don't need to input negative signs because you already know when you use a negative number divided by another negative number, the result is positive. So we just input these two numbers, 2.448 divided by 4.8, because we already know the answer will be positive. So 0.51. And that's our final answer. If you want to check, let's check it once. So if our answer is correct, we plug it in here, replace t with 0.51. Both sides should be equal. So let's double check. 6 minus 4.8 times 0.51. If we get the number on the right side, our answer is correct. So 6 minus 4.8 times 0.51 equals 3.552. See, we have saved number. That means this answer is correct answer. Now, let's look at the second example. You may see already that this equation is exactly the same equation we just finished, but we are taking a different approach. you see this learning objective. We are going to eliminate decimal numbers from a given equation by using the multiplication principle. So how do we eliminate all of these decimal digits? It's not that we just ignore them. We need to move decimal points. This one, you need to move 1 point to the right. This one needs 3. So we always look at the largest number of decimal places we need to move to do this whole thing. So 3 digits for every number. That means we need to multiply 1,000 by using each number. Just move 3 digits to the right by each number. So we have 6,000 minus 3 digits, okay, 4,800 t equals 3,552. This way we only have whole numbers. And for the rest of the steps, we're going to do exactly the same thing. First, we eliminate this number by itself. So we subtract it on both sides. We got negative 4,800 t equals, if we do that, we're going to get negative 2,448. Let's use a calculator to verify that. 3,552 subtracts 6,000 equals negative 2,448. Now, one last step, we're going to use this number divided by this. Remember in the last example, we divided by this number on both sides. So negative 2,448 divided by negative 4,800. And I'm sure we're going to get the exact same answer. It's just a different way to do it. It's not different equation. So 2,448 divided by 4,800 equals 0.51 as expected, right? So we got the exact same answer. Now let's look at another example. In this one, notice that we have parentheses, right? And when we learn the order of operations, it says we need to do the operations inside parentheses first. That's only good when you have numbers only inside parentheses. You cannot do x minus 12 or x minus 1.2 in this case without knowing the value for x. We cannot do that. That's why in algebra, we have other way to work with parentheses. That is, you multiply each number inside or variable, everything inside, by this number outside. In other words, we need to do a distribution to remove the parentheses so that we can combine like terms afterwards. So let's do that. 0.3 times x, that's 0.3x. Then after you multiply by x, x is gone. Imagine that x is gone. The only thing left is a negative 1.2. Positive times negative will be negative. When you multiply it together, you got negative 0.36. So we can double check. 0.3 times 1.2, 0.36, but it's negative. On the other side, we get 1.46. Now, if we don't have any number outside, it's equivalent to 1. Okay, 1 times anything won't change anything. Basically, we just minus everything inside parentheses 1 by 1. So minus 2.1x minus this positive number, so minus 0.22. If this is a minus 0.22, you have minus minus, it's going to be plus. So now what we do? We combine like terms. So these two are like terms because they both are numbers. So we can combine them together. So let's do that. I just copy this 2 on the left-hand side. 1.46 minus 0.22. 1.46 minus 0.22. You get a 1.24. So 1.24 minus 2.1x. Now, next step, we want to have x terms on one side by itself, number on the other side. So to eliminate anything, we do opposite operation. Since I want x on the left-hand side, I just eliminate this x term on the right-hand side by adding 2.1x, adding 2.1x. I can also eliminate this number from the left-hand side because we need x on the left-hand side, number on the other side. This is the minus, we do plus. So we can do this two at the same time, plus 0.36. Now let's see what we get. 2.1 plus 0.3, that's 2.4 for x. And this is gone, canceled. And this is gone, x terms are gone on the right-hand side. These two combined, 1.24 plus 0.36, that's 1.6. Let's just double check this is correct. So 1.24 plus 0.36. We get 1.6. Now we only have one step to go. We divide by 2.4 on both sides. And this is 2/3. 2/3 is 0.666 forever. So if we round it, let's just do the division so that you can see it. Divided by 2.4, say 0.66 forever, or 0.667, depending on how many decimal digits you want to have. And if you plug in this and both sides, it's not going to be exactly equal this time because we rounded, but should be very, very close on both sides once you plug in. So let's do that quickly. So I'm going to use the 3 decimal digit. Again, I expect some differences between both sides, but the difference should be tiny. So this is 0.3 times parentheses 0.667 minus 1.2 close the parentheses equals. So on the left-hand side, we got negative 0.1599. Let's look at the right-hand side. So 1.46 minus parentheses 2.1 times x, which is 0.667, 0.667, and then plus 0.22, and plus 0.22, close the parentheses, equals, now look at this number, negative 0.1607. These two are really, really close because this one is really close to 0.16, this one 0.1607. So difference is in the 4th digit. So if I want to use 0.16, let's just only look at number minus 0.1599. Let's see the difference. 0.1607 minus 0.1599 equals, you see, only the difference in the 4th digits. Difference is really small. If you take more digits here, the difference is even smaller. So we get the right answer. If you use a fraction with 2/3, they are going to be absolutely equal to each other on both sides. Now let's look at some story problems. We also call them application problems. So in general, we want to set up equation and solve equation to answer a application problems. So this one says 5.9 more than 0.2 times n is equal to 6.7 less than the product of 1.4 and n. Translate this description to an equation, then solve it for n. So let's translate this sentence or statement into equation. 5.9 more than 0.2 times n. So 0.2 times n you have something 5.9 more than that, you have to add this 5.9 to it to be more than that. So the other side is equal to this one, this right-hand side is 6.7 less than the product of this two. Product of this two is 1.4 times n. 6.7 less than that. You have to subtract 6.7 to be less than that by 6.7. Now we just translate it into equation. Now time to solve it. Now, as usual, we need to get rid of n on the right-hand side. So I subtract 1.4n. Subtract 1.4n. Then I also need to get rid of 5.9 from the left-hand side so that we only have number on the right-hand side, right? So subtract 5.9. We always do the opposite operation on both sides. So 0.2 minus 1.4 is negative 1.2n. Let's do that using calculator. 0.2 minus 1.4, negative 1.2, right? And this two canceled. This two canceled. We get negative 6.7 minus 5.9. Make sure you do the calculation right. And from my head, it's going to be negative 12.6. But let's check it using calculator. When you use the calculator, make sure you know the difference between minus and negative sign. For my calculator, this is negative, and this is the minus. They're far away from each other, so that people know they're different. So I get negative 6.7 minus 5.9. Negative 12.6. Now all I need is to divide by negative 1.2 to get n. So negative 12.6, negative 1.2. Again, negative divided by negative is positive. All we need is 12.6 divided by 1.2. 10.5. So that's our final answer. N is 10.5. So if we plug in, both sides should be equal. Now another application problem. See, we're going to have two different ways to solve it. Essentially, they are the same because you have same problem, but just different way to represent the information in the description. Karen uses a cell phone service that charges $39.99 per month for 450 minutes. After that, it will cost $0.4545 for each additional minute. If Karen's total bill is $82.29, how many total minutes did she use? So first approach, we can use X to represent this unknown total minutes. Total time in minutes. After that, after you represent unknown using variable, now we can represent the information by equation in the form of equation to represent the information. Once you represent the information, you can solve it for the unknown. So setting up equation actually is very straightforward. Don't make it more complicated unnecessarily. You just need to look for some fact and represent it. This one is that the total cost is $82.29, right? Total cost is split into two portions because that's the rule. For the first 450 minutes, it will cost $39.99. That's a fixed amount. Beyond that 450 minutes, every actual minute will cost her 45 cents. So in other words, first, we're sure that she called more than 450 minutes because this total bill is more than $39.99. Makes sense, right? So I'm going to write this whole thing into two parts. First, $39.99. That's for that 450 minutes. Then for additional minutes, it will cost her 45 cents per minute. How to represent additional minutes? Those are the minutes beyond 450, right? Remember, X is total minutes. If we subtract 450 from it, the rest must be the minutes beyond 450, right? So each of these minutes will cost her $0.45. Together, the total cost is $82.29. You see, I just represent the fact, the basic information. Now let's solve it. So 39.99 plus, we distribute everything inside. X times 0.45 is 0.45x minus these two multiplied together. So 450 times 0.45. We get 202.50. 102.5 and equals 82.29. Now we just need to solve this equation. Apparently these two can be combined, so we combine them together. Actually, we can just do opposite operation on both sides. So we minus 39.99, we plus 205.5. We just need to do this on both sides. We minus 39.99, we plus 205.5. And they all canceled. We get 0.45x equals, let's do this calculation on the right hand side. So I get 82.29 minus 39.99 plus 205.5 equals 247.8. Now, one last step, we just divide by 0.45, right? So I still have this on screen, so I just divide it by 0.45. So totally 550.6. They ask us how many minutes. They didn't mention rounding, so just take 2 decimal digits. Total number of minutes. Now let's look at the second approach. We're supposed to get exact same answer. Now, second approach is that we can think about, we know that she cut more than 450 minutes. So we can let X to represent those extra minutes beyond 450. So each of those minutes will cost $0.45. So this is total cost, this number of actual minutes. This is total cost beyond that 39.99. So the other side must be 82.29 minus 39.99. Anything on the right-hand side represents the cost for those additional minutes. So let's do that. 0.45x equals, let's do this subtraction. 82.29 minus 39.99. We get 42.3. Now let's do the division. X equals 42.3 divided by 0.45, right? 42.3 divided by 0.45. We get 94. 94. This is actual minutes. So the total minutes will be 450 plus 94. So 450, I just add 450 to it. They get 544. So total is 544. These two are different. Apparently one of this is wrong. more than likely this is wrong. Let's double check my calculation. 3999 0.45x minus, I'm going to double check this multiplication. So 450, mistake happens sometimes, times 0.45, 202.5. See, that's a like typo. It was 202. I wrote it at 205. 202. 202. That make a big difference. Let's redo this. Redo this number. So that's 82.29 minus 39.39 plus 202.5 equals 245, 245.4. Now let's do the division. I still have that on my calculator, divided by 0.45. Oh, still different. 245.4, is that right? 245.4 divided by 0.45 equals, oh, let's double check. This is 202.5, this is 202.5. Yeah, let me redo the calculation on the right hand side. 82.29 minus 39.99. I guess this is my careless calculation. Plus 202.5 equals 244.8. See, 244.8. Now divided by 0.45. So 544. So 544 is the final answer. She totally caught 544 minutes. Okay, now let's look at some geometry problems on the next page. So first, this geometry problem is about the Pythagorean theorem down here. And this Pythagorean theorem only can be applied to a right triangle. A right triangle is a triangle that has a 90-degree angle in it. So you have two sides that are perpendicular together. So that's how they form this right triangle. This is a symbol for right angle. And the other side is called hypotenuse. Then what does this Pythagorean theory say? It says the relation among the length of the three sides goes like this. If you add the square of each of these two perpendicular sides, we call them legs, it will be equal to the square of the length of this hypotenuse. So in other words, how we use this theory, it goes like this. Whenever you're given any two out of these three sides, you can solve for the third one. All you need to do is represent these three sides using given information, using this formula. Whatever the question you have, always use the same formula, as long as you have a right triangle. Now, let's look at this example down here. To steady a telephone pole, a wire is to be attached 21 feet up on the pole. So that's here, 21 feet tall for this, for the height of this wire. And then attached to a stake 20 feet out from the base of the pole. So 20 feet out on base of the pole. So we are given, apparently this is a right triangle, right? So apparently we are given these two legs. Then the question is, what length of the wire will be needed between the pole and the stake, between the pole and the stake? So they ask us for the length of the hypotenuse. So we realize that this is a right triangle. We are given two sides. We are solving for the third one. So we just use that formula. That formula says the square, the sum of the squares of these two legs, which is 21 square, the other one is 20 square. And it must be equal to the square of the hypotenuse. This is our x, or x squared. Now the rest, just solve it. So 21 square it should be 441. So let's do that. 21 square, 441. So 441 plus 20 squared is 400 equals x squared. This 841 equals x squared. Now to find x, we do the opposite operation. The opposite of square is a square root. So x equals square root of 841. So let's do that. Square root 841 equals 29. So exactly 29 feet. So that's our answer. Now we have another example, and it's right here. How high up on the side of a building will a 20-foot ladder reach if the base is placed 8 feet from the base of the building? The graph is on the next page. So basically, we have a 20-foot long ladder. We want to put it against this building. And we are told that the distance from the bottom of the ladder to the base of the building is 8 feet. We want to know how high we can place this ladder against the building. We're looking for this part. This is going to be our x. So apparently this time we are solving for one of these legs, right? It doesn't matter what we are solving for actually in terms of setting up equation. As long as you have a right triangle, you do the same thing. The sum of the squares of these two legs, so x squared plus 8 squared is equal to hypotenuse squared, which is 20 squared. So now we just solve f of x. X squared plus 64 equals 400. Subtract 64 on both sides. So we get x squared equals 336. Now we're going to take a square root of 336 to get the height. I mean, how high we can go. So 300 square root 336 equals 18.330303. So it's about 18.33. Yeah, feet. So that's our answer. Make sure your answer is smaller than the hypotenuse, because each leg must be smaller than the hypotenuse to have a right triangle. Example 7, that's the last one for this video. Betty tells her son that, so this is a problem that involves two unknowns. Betty tells her son that she has 15 coins in her change purse that total $2.85. If she keeps only quarters and dimes in her change purse, that means all of those coins are composed of quarters and dimes. How many of each coin does she have? So we don't know how many quarters, how many dimes. So that's two unknowns. In theory, in algebra, you can set up this equation in two variables. But in algebra, in order for those equations to be solvable, the number of unknowns, the number of variables you have to be equal to the number of equations you have. In other words, we could use two variables to set it up to solve this problem, but we need to have two equations. But in this particular example, I'm going to show you how to set it up using one variable, even though we have two different unknowns. As long as those unknowns are related, you can represent all of the unknowns in one variable. In this case, we only have two. Are they related? Yes, because those two unknowns, two number of coins added together must be 15. That's how they related. They add to 15. So I let X to be the number of quarters. You can use X to represent number of dimes. The result is the same. So now I need to set up equation. So how do we know how many dimes are in there? Since the total is 15, if X represents number of quarters, the rest of coins must be the number of dimes. So number of dimes is 15 minus X. This is the number of dimes. Now with this, we can set up equation. Equation is nothing more than representing a relation of all of these quantities, okay? The total value is this. Apparently, from common sense, the total value from quarters plus the total value from dimes will be equal to this number, right? So each quarter is worth $0.25, and we have this many quarters. So let's multiply them together. Then plus the value from dimes. How many dimes we have? This how many dimes? Each dime worth $0.1, but we have this many dimes. Multiply them together. So this must be $2.85. Notice that I used 0.25 and 0.1. I didn't use 25 cents, 10 cents, because we have to have same unit. This is in dollars. It have to be in dollar. Now expand it so that we can combine them. 0.25x plus 0.1 times 15 is 1.5 minus 0.1x equals 2.85. Now these two can be combined. 0.25 minus 0.1, we got 0.05x plus 1.5 equals 2.85, right? Now we need to get rid of this 1.5, do it on both sides. 0.05x equals, this should be 1.35, but let's do it using calculator, double check. 2.85 minus 1.5, 1.35. So to get X, we just divide both sides by 0.05. And we're gonna have 27, but let's check. 1.35 divided by 0.05. 27. So we have 27 quarters since we use representative quarters. How about number of dimes? Quarters, okay, 27 dimes. Dimes is 15 minus, well, something is wrong apparently. Total coin is 15. Let's check with my calculation, 0.25x plus 0.1 times 15, that's 1.5, that minus 0.1x, that is correct. And 0.25 minus 0.1, that's 0.15. That's my bad, apparently. I'm too confident. That's the problem sometimes. So 1.35 divided by 0.15, 36. Oh, 36, even more wrong. 1.35 divided by 0.15, 9. That'll make more sense now. So quarter is 9, dimes is 15 minus 9, that's a 6. Now, 9/4, 6 times. Let's double check if this is true. Total value is 2.85. So 9/4 times 0.25 and 6 times 0.1. Let's see what we get. 9/4, that's $1.44. But let's check again. Times 9. $2 something, $2.25. 0.25, 0.25 times 9, $2.25. $2.25 plus 0.6, because 6 times is 60 cents. So this is $2.85. That's correct. So this is the final answer. So 9/4 and 6 times. And that's all for this video.